Hello everyone and welcome to this video which explains the challenges of shared local area network LAN. Overview. LANs are relatively low-cost means of sharing expensive resources so that they allow multiple users in a fairly geographic area to exchange files and messages and to access shared resources such as file servers. LANs have rapidly evolved into support systems that are critical to communications with an organization. This video explains the challenges that shared LANs face as they confront the increasing need for bandwidth and speed to satisfy the needs of multiple users. Upon finishing to watch this video, you will be able to identify issues related to increased traffic on an Ethernet LAN. Ethernet LAN segment limitation. Segment length is an important consideration when using Ethernet technology in a LAN. A segment is a network connection of two devices or more that is made by a single unbroken network cable. Ethernet cable and the segment can span only a limited physical distance. Beyond this distance, transmission will become degraded because of line noise, reduced signal strength, and failure to follow carrier sense multiple access with collision detection specification. For example, when using ETP cabling for Ethernet, it has a recommended maximum distance of 100 meters. Fiber optic cables may provide a greater cabling distance, approximately 550 meters or up to a few miles, depending on the technology. Four data rates are currently defined for operation over optical fiber and twisted pair cables. The first is 10 megabit per second or 10 base T Ethernet. The second is 100 megabit per second for faster Ethernet. The third is 1000 megabit per second for gigabit Ethernet. And the last is 10 gigabit per second for 10 gigabit Ethernet. Each type of Ethernet specification has a defined set of cables type, data rate, and modulation technique, which in turn defines a maximum segment length. How to extend a LAN segment? You can add devices to an Ethernet LAN to extend the segment. A hub is a physical layer device that takes a signal from a device on the network and acts as an amplifier. Adding a hub to a network extends the network so that data can be communicated successfully over long distances. Therefore, a hub retransmits the signal to every port to which workstation or servers are connected. Also, hubs do not read any of the data passing through them, and they are not aware of the source of the destination of the frame. Essentially, a hub simply receives incoming bits, amplifies the electrical signal, and transmits these through all of its ports to the other device on the network. It means that a hub extends but does not terminate an Ethernet LAN. The bandwidth limitation of a shared technology remains. All users of a given Ethernet segment compete for the same amount of bandwidth. A significant development that enhanced LAN performance was the introduction of switches to replace hubs in Ethernet-based network. This development closely corresponds with the development of 100 base TX Ethernet. Switches can control the flow of the data by isolating each port and sending a frame only to its proper destination. This functionality is much better than sending every frame to every device. Like hubs, switches do amplify the signal and extend the cable distances. They also extend a LAN to cover greater distances by joining multiple LAN segments. In general, switches are chosen for connecting devices to a LAN. Collision are part of the operation of Ethernet, occurring when two stations attempt to communicate at the same time. Collisions are byproduct of the CSMA/CD method that Ethernet uses. In Ethernet network, many devices share the same segment. All devices have granted access to the medium, but they have no prioritized claim on it. Ethernet uses CSMA/CD to detect detect and manage collision, and process the resumption of communication. In the CSMA-CD access method, all network devices that have messages to send must listen before transmitting. If a device detects a signal from another device, it will wait for a specified amount of time before attempting to transmit. When no traffic is detected, a device will transmit the message. Despite listening to see if the media is free, station may transmit simultaneously. If two or more stations on a shared media transmit at the same time, a collision occurs and the frames are destroyed. When the sending station recognizes the collision event, they transmit a special jump signal for a predetermined time. The devices on the segment will know that the frame has been corrupted and they will stop communicating. The sending station will then begin a random time that must be completed before attempting to transmit the data. As networks become larger and use more bandwidth, it becomes more likely that station will attempt to transmit data simultaneously and the collision will occur. The more collision that occur, the worse the congestion becomes and network accessibility can become slower or non-existent. What is a collision domain? In expanding an Ethernet LAN to accommodate more users with more bandwidth requirements, you can create a separate physical network segment called collision domains. Collisions are then limited to a domain rather than the entire network. In traditional Ethernet segments, the network devices compete for the same bandwidth, with only one device being able to transmit data at a time. The network segments that share the same bandwidth are known as collision domains. When two or more devices within that segment try to communicate at the same time, collision may occur. All shared media environments, such as those created by using hubs, are collision domains. It is possible, however, to use other network devices operating at layer 2 and above of the OC model to divide a network into segments and reduce the number of devices that are competing for bandwidth. Each new segment results in a new collision domain. More bandwidth is available to the devices on a segment, and the collision in one collision domain do not interfere with the working of the other segment. This figure shows a unique collision domain in a switched environment. For example, if a 12-port switch has a device that is connected to each port, 12 collision domains are created. When a host is connected to a switch port, the switch creates a dedicated connection. This connection is considered an individual collision domain because traffic is kept separate from all other traffic, therefore eliminating the potential for a collision. The broadcast domain. The broadcast domain is another key concept. Switches perform filtering of frame that is based on MAC address within the frame. This filtering does not extend the filtering broadcast frame. By their very nature, broadcast frame must be forwarded. Therefore, a collection of interconnected switches form a single broadcast domain. It takes a layer 3 entity, such as a router, to terminate a layer 2 broadcast domain. What is the role of CSMA/CD in Ethernet? Ethernet signals are transmitted to every host that is connected to the LAN using a special set of rules to determine which session can talk at any particular time. Ethernet LANs manage the signals on a network by carrier sense multiple access with collision detection, which is an important aspect of Ethernet. Station on a CSMA/CD LAN can access the network at any time. Before sending data, CSMA/CD stations listen to the network to determine whether it is already in use. use. If it is, the CSMA CD stations wait. If the network is not in use, the station transmits. A collision occurs when two stations listen for network traffic, hear no one, and transmit simultaneously. In this case, both transmissions are damaged and the stations must transmit at some later time. CSMA CD station must be able to detect the collision to know that they must transmit. When a station transmits, the signal is referred to as a carrier. The NIC senses the carrier and consequently refrain from broadcasting a signal. If there is no carrier, a waiting station knows that it is free to transmit. This functionality is the carrier sense part of the protocol. The extent of the network segment over which collisions occur is referred to as the collision domain. The size of the collision domain has an impact on efficiency and therefore on data throughput. If the CSMA/CD process priorities are not assigned to particular stations, so all stations on the network have equal access. This functionality is the multiple access part of the protocol. If two or more stations attempt a transmission simultaneously, a collision occurs. The stations are alerted on the collision and they execute a back-off algorithm that randomly measures the transmission of the frame. This scenario prevents the machine from repeatedly attempting to transmit at the same time. Collisions are normally resolved in microseconds. This functionality is collision detection. This is the end of the video. Thank you for watching. If you are interested, subscribe.